Right. So I'm finishing up my example, at least the main part of the calculation. We just to review, we started with a function and an interval. We and the number of boxes that we started with was 7. So we learned how to split up uh, the interval from 1 to 3 into the correct number of points. And for the left endpoint one, we were choosing points to the left of the box we were creating. And so we came up with a sequence x1 through x7. And that is what we are saying when we say x sub I, is the index, is increasing, and it's just going from one x value we've chosen to the next. So really the tricky part here is, or in the last video, was to actually come up with an expression that as I changes from 1 to 7, that this piece in here gives us the x values that we have in fact chosen to use, and that are correct. The other thing we noticed was that we found a way to calculate delta x using the endpoints. The difference between the endpoints is 2. 3 minus 1 is 2, and then we just divide by n. So it would be 2 over n, or in this case 2 over 7. And that's how we came up with these in the first place, but that's also the constant value here of the actual difference between one x and the other. In other words, it's the base of each rectangle is 2/7. All right, so just to recap, 2/7 is the delta x. It's a constant. We know what it is. Even if it's n, 2 over n is going to be constant because this value right here is going to remain constant. And so we bring it out front. So what we have currently is 2/7 times the sum from 1 to 7 of the function value at each of these points. As I goes from 1 to 7, you get first 1, then 1 plus 2/7, and 1 plus 4/7, and so on. But we're not even going to bother to calculate that out, because what we want is an actual result that then we're going to be able to just change the 7 into an n and see what happens from there. Okay, so what we said in the last video is we actually plugged in x sub I into this function, and we saw that what we got was 2/7 times the sum from 1 to 7 of 16 minus the sum from 1 to 7 of 1 plus, I'm going to actually write this out, that's 2i over 7 minus 2/7, and that's squared. Now, the reason I'm doing that is because we actually need to calculate this, and that's the annoying part. So maybe let's combine everything. Let's off to the side figure out what that is going to be. All right, just before I erase this, the only further calculation we did was multiplying the 7 by the 16, because we know what the formula for this is. If it's just a constant and you're taking the sum up from 1 to a certain number of that constant, then you just multiply the 2 together. That's just 7 times 16. Okay, so we're not going to bother with that right now. What we're going to work on is what happens here. This is a mess. This is the mess that we are trying to deal with. So let's do that. We are, hold on, before we say equals, we need to add, well, 1 is 7/7, so maybe I should do that. 1 minus 2 sevenths is 5 sevenths. 5 sevenths plus 2I over 7. Yes, so I am actually going to recombine the denominators, because what does this give us? Let's just write the 2I first. 2I plus 5 over 7. Now when we square that, we get the top squared and the bottom squared. And we can write that as 1 over 7 squared times 2I plus 5 being squared. Now, why would we do that? Well, the denominator part is a constant, so we can bring it out and not worry about it. And then in here, what would happen is this would be FOILed out. So again, the constant part, 1 over 49, times 4I squared. Now, don't get confused with imaginary. This is not -1 or anything. This is just the index. 4I squared plus 2 times 2I times 5, so that's 20I. You'll get this by FOILing this out. And then 5 squared is 25. Okay? So this part right here, you actually have the sum of 1 over 49, 4I squared plus 20I plus 25. Goodness. All right. Let's deal with that now. Okay, we're going to get rid of all this. All right. So in other words, when we have this right here, well, this whole thing actually, what we actually have is we have, let's do this part. Remember, this is 7 times 16, so we have 2 sevenths times 7 times 16. Okay. And then we have minus 2 sevenths. And this part, remember, is the sum from I equals 1 to 7 of, I am going to keep that just 1 over 7 squared, 1 over 7 squared, 4I squared plus 20I plus 25. Okay, so again, this is a constant. We can bring it out front. These do actually cancel, whether it's an n or not. They're exactly the same. So you have 2 times 16. Okay. Minus 2 over, and I'm going to write this as 7 cubed, because we have 7, and then we're bringing out 2 over 7, 2 over 7 times 7 times 7. And then here, just a little more space. Here, what we get to is a problem like the one I showed you in part 4. So here we get to the sum. The sum from I equals 1 to 7 of 4I squared plus the sum from 1 to 7, you guys know that it's an I equals, of 20I plus the sum from I equals 1 to 7 of 25. Okay, now this part breaks up even further. This is 32. This is 2 over 7 cubed. And this, as you may recall, we can bring out each constant in turn. I'll just do it in different colors so it's obvious. Okay, and then we have the sum from 1 to 7 of I squared. Well, what is that? That's 7 times 7 plus 1, whoa, times 2 times 7 plus 1 all over 6. And this is 20. They bring the constant out. This is so messy. All right. And then the sum from 1 to 7 of I is just the 7 times 7 plus 1 over 2. And then the last one is, well, it's just 25 times 7. Okay. All right, now there are a lot of things going on here, but what do you notice that is part of every single one of these? There is a 7 in every single factor. 7 here, there's a 7 multiplied by this whole thing right here, and there's a 7 multiplied by this whole thing right here, and so we can get rid of all of those along with one of these 7s here. Okay. What else? Well, I think at this point, I feel like I've shown you enough of just with the 7s. You can, from this point, you can add these things together and see what you come up with for a number. But again, the reason I'm showing you this is so you can see what's going on when we just have n. Okay, so we still have the 32. The n's, if this was n, those would have canceled anyway. Minus 2 over n squared. And then we have this whole weird thing going on. All right, I do not have enough space for this, so I'm instead going to give you the numerical thing. Oh, goodness. Let's see what happens here. Well, how about you give me what you get for this as a number for this answer here. We'll just call it here. That is the process for actually getting one of these area estimations. I think I've walked you through the entire process. Now, some of this I was trying to keep more complicated than you'll probably do. For instance, I mean, if you have the 2 7ths, you bring out the 1 7th. 1 over 7 squared, I mean, you don't need to write that as 2 over 7 cubed, but that's actually not that big of a deal, I think. Some of this stuff, though, like 7 plus 1, you could have written an 8. 2 times 7 plus 1, you could have written a 15. And then you could just calculate it, divide it by 6, divide this by 2, and so on, come up with an answer. But this is the conclusion of the entire process, and it is a really, really long, complicated process. That's why I will probably have you guys work up to doing a single one of these, and we will see how that goes. All right.